Hello, this is week 12 of the semester, and this week we're concentrating mainly on section 5.1. And section 5.1 is one of those few sections in this course that is very computational. There's very little calculator work per se. There may be some numerical calculations, but there's no work on the calculator. It's very algebraic, numerical, arithmetic, and then interpretation of graphs. And the topic in 5.1 is actually combining functions. That means you're combining them maybe by arithmetic operations like adding, subtracting, multiplying, or dividing, or it could be a composition like you see here in part 2. And you know, almost every section we end up with some word problems, some real life problems applying what we have done in that week. So we're going to start out with our arithmetic operations. So you're given, in this example, you're given two functions. F of x equals 2x minus 3, which is a linear function. G of x equals 1 minus x squared, which is actually a quadratic function. And you're asked to evaluate the following expression. So one thing you need to always realize is that this number here that you see is actually taking the place of x. And by the way, I took only parts A and C out of this problem from page 395. So when you're looking at part A, and it says f plus g of 3, that is saying that x equals 3. So what you're going to do is you're going to substitute that x equals 3 into f. You're going to substitute that x equals 3 into g. But the operation between them is a plus. So now what we're doing is we're substituting every place where there's an x in f of x, we're going to substitute in for 3. So we have 2 times x. In place of x is a 3 minus 3 plus. Now here in every place where there's an x in g, we're going to substitute in for 3. So we have 1 minus 3 squared. And now we're going to simplify it. So we're going to do what is inside the brackets first. We multiply first, so that will give us 6 minus 3 plus. We do what is inside the brackets first, and squaring has priority. So we're going to have to square 3 first. So 3 squared is 9, so that will be 1 minus 9. Continue working inside the brackets. 6 minus 3 gives us 3, plus 1 minus 9 gives us negative 8. Now we combine those two, and they have opposite signs, so our final answer will be a negative 5. 8 minus, or 3 minus 8 equals a negative 5. And that is the answer for f plus g of 3. Now we're going to look at part C, and it says fg of 0. So first of all, make sure you realize this means multiplication and the x equals 0. So you're going to substitute that x for 0 into f. So you're going to find f of 0. You're going to find g of 0. You're going to substitute the x equals 0 into g, and whatever the results are, you're going to multiply them. So now we do the substitution. And remember, this means x equals 0, so we're substituting x for 0 into the formula for f in place of x. Then here, g of 0, x equals 0. So we're substituting x for 0 into the function g of x. So now we're going to do our calculations inside the brackets. And 2 times 0 is 0 minus 3 times. And then we have 1 minus, and then 0 squared is 0. So 0 minus 3 gives you a negative 3. That minus becomes a negative and it belongs to 3. However, here the order is different. 1 minus 0 is just a 1. So negative 3 times 1 will give you negative 3. And that is your final answer. Save that. Now the next exercise is more algebraic. Notice there are no substitutions for x. You're given f of x equals x squared minus 1 and g of x equals x squared plus 1. And in part B, it says f minus g of x. What that means is you're going to take whatever f of x is, whatever g of x is, and you're going to actually subtract it. So I'm going to substitute f of x for the formula that you're given, which is an x squared minus 1, minus, and you're going to substitute g of x for the formula you're given, which is an x squared plus 1. And so your answer is going to be another formula in terms of x. So now we have here, I can go ahead and get rid of the parentheses, but here I have to distribute that negative. So that becomes a negative x squared minus 1. And notice what happens is the x squared minus x squared are going to cancel out, and your final answer will be a negative 2. So it happens to be numerical, but we didn't have a number for x. With that formula, f minus g of x ends up being just a negative 2. Now, part D says f divided by g of x. So technically, if we have f divided by g of x, what it means is that you're going to take f of x over g of x. And it doesn't always necessarily mean that you divide, but you form a fraction. So you substitute f of x for an x squared minus 1 over, you substitute g of x for the x squared plus 1, and then now that becomes a whole new formula, and that is the answer for the f divided by g of x. That is very algebraic, very symbolic, and you don't have numerical answers necessarily. So the second part of this function is working with compositions of functions, and compositions of functions also involves operations with functions, but it's not always multiplication, it's not always division, it's not always addition. It's basically substituting one function into the other. So one thing that is very, very important is you're going to notice the notation. It's going to have like a little circle, not a dot. That is called G composition of F. And this is very important. Notice that whatever is closer to the x, whatever function is closer to the x, becomes the inside function. And that is the key to everything we do here. So here's a specific example. We're given f of x equals the square root of x plus 5, and g of x equals x squared. And in part A, you're asked to find f composition of g of 2, and this is your x value. So F composition of G of 2. Think about what I said. Whatever is closer to the X, that's what's substituted in first. So this is actually F of G of 2. And that's what I'm going to do first. In fact, I'm going to do it in a little box here. I'm going to find G of 2. That means X equals 2. So I look at the formula for G and it has an X squared. So I substitute X for 2. 2 squared will give me 4. So that means G of 2 is equal to 4. So then I go back to my composition here and I have F on the outside and then it says G of 2 and G of 2 is that 4. So I'm going to substitute the whole thing for 4. Now forget about G and forget about that X equals 2. This is saying find F of 4. That is saying wherever you have X in F, you're substituting for 4. And the formula for F is the square root of X plus 4. So in place of X, you're going to have a 4. 4 plus 5, that will be 9. So you have the square root of 9. And then F composition of G of 2 turns out to be a 3. Now, in the next example, notice in part B, notice that you have G composition of F of -1. And the X is a -1 this time. But notice that is F one that is closer to that X equals -1. So when you're looking at part B and you have G composition of F of -1, then this is done first because F is closer. F becomes the inside function. So then you have G of, and you're going to evaluate F of -1 first. And I like to do that on the side, a little box, find F of -1. Now this X equals -1, and we go to the formula for F. Notice that F is the square root of X plus 5. So then I'm going to have square root of -1 plus 5. That gives us the square root of 4. And F of -1 turns out to be a 2. So now I go back to the original. I have G of, but instead of a -1, now I'm going to substitute in for 2. And now forget about F. Forget about that X equals -1. This is saying that X equals 2, and we are substituting that into G. And the formula for G is an X squared. So now I'm going to substitute that X squared, that X for a 2, and I'm going to square it, so I get a 4. So G composition of F of -1 equals 4. And that is your answer for the composition. Now, sometimes with the composition, you have some exercises that have to do with boxes, numerical values. But the key is still understanding what the order means. So we're going to look at G composition of F1. This is an X, but the important thing is F is closer to 1. So that means we're going to evaluate F of 1 first. And this is X equals 1. So where do you find that value? You go to the table that has F. Notice here are the X's. Here are the F values. you're looking for 1. So when x equals 1, f of x equals 4. So that means this will be substituted in for 4. So then you have g of 4. Forget about the f, forget about the x equals 1. Now we start all over again. And this here is telling you that x equals 4. But now we're using g. So here are the x's, and here are the g values. And we're interested in x equals 4, then g equals 5. So your final answer is going to be 5. Now let's look at another example. This time we have B. Part B is F composition of G of 4. So this is X, and the key is that G is closer to that X. So that will be substituted in first. That will be F of, and then we substitute G of 4. Now that means X equals 4. So we go in and we substitute that into G. So we go to the table for G and we find X equals 4 and G is equal to 5. So then we can substitute that G of 4 is a 5. That's an X. And then forget about the G, forget about the X equals 4. We look at the function F and we substitute that that X equals 5 into F. So we go to the table where F is and we look for a 5, and there is no 5 in there. So I don't think that we can actually answer this because there is no X. Cannot be found on the table. Okay, so let's try part C. And that is F composition of F. And this is a little bit tricky because we have F twice. But again, we're going to do that one, first right here. So we have F on the outside, and then on the inside, I'm looking for F of 3. So X equals 3, go into F. So when X equals 3, F is equal to 1. So we have F of 1. And then forget about the X equals 3. Now the X equals 1, but we're still using F. So I go to the table for F, and X equals 1, and the answer would be 4. Now, the last part of this section, it deals with word problems, and is looking at a graphical approach. And basically what is happening is we are looking at what are the temperatures after 1 hour, 2 hours, 3 hours. And that's what the function f of x does. It gives you the temperatures in Fahrenheit after 1 hour, 2 hours, 3 hours, and 4 hours. However, the function g of x is taking whatever the Fahrenheit temperature is and changing it into Celsius. So you notice here, the graph of g of x, these are the temperatures in Fahrenheit, and these are the temperatures in Celsius, where in F, the x values are the times in hours, and the y values are the Fahrenheit temperatures. And okay, so now we're gonna evaluate based on the graphs. And remember that in the composition, what is closer to the X is what is evaluated first. So I have G of F of 2. So to find that F of 2, I go to the graph of 2. Remember, this is your X. So I look at X equals 2. I find my Y value, and I'm going to have to guess because that's going by increments of 4. So it's somewhere between 76 and 80. So maybe 78 or 77. So I'm going to say that it's approximately equal to 77. But that's actually just my inside function. Sorry. So I have G of 77. Okay, so when I evaluate the second part, I have to look at the second graph. And this is the X value this time, 77. So I go here, and this one, it looks like it's going by increments of 5 units. So about a 77 would be about right here. So when I look at the Y value, it looks like it's about a 25. And that gives you that this is 25 degrees Celsius. So this is saying that after 2 hours, the temperature is 77 degrees Fahrenheit and is 25 degrees Celsius. Now, it asks you to interpret it. So like I said, after 2 hours, the temperature in Fahrenheit is 77 degrees Fahrenheit, which is equivalent to 25 degrees Celsius. So it's converting those temperatures from Fahrenheit to Celsius in one step. So these are some examples of what you're going to see here in section 5.1. Keep asking questions in the current discussion. And I always welcome those there. Make sure you ask questions.